Hello, dear viewers, and a very warm welcome to the official DPLABS channel.
Today we have a truly impressive presentation featuring the largest Tesla coil on our entire continent. A huge and sincere thank you to the guys from Tesla FX. They thoughtfully reached out to me and wanted to test it in a wide open area, primarily because it's so incredibly awesome that it's simply impossible to test it indoors.
The show will officially start in exactly 15 minutes from now. I sent it to Kirsten and he was like, oh, I'm going home. They put on a show. No, the guys really do put on shows, but not with this huge one. They do it at concerts, even at the White House. No, I absolutely get it. He was like, come on, the really big one. Well, yes, indeed. Oh, let's definitely film this guy. Please come over here. And right here with us as our very special guest is the one and only, everyone's absolute favorite, the incredible Igorek. That's precisely how it is, you see. Hello, everyone. We're about to have some truly fun...
Basically, in essence.
How did you actually come up with this idea?
It was quite spontaneous. I was driving back from Crimea, and Dmitry called and said, we really need to make it look good.
So friends standing over on this side, I'm talking to you. Don't be shy, please come up to the table and help yourselves. There are refreshing alcoholic drinks and delicious snacks available, so I invite you all.
We're all good here. Do you want to film?
From inside the cage?
Is it truly safe for her, really? Well, I wonder.
You need to stand at a certain distance. In the cage. Right inside the cage? Yeah, that's fine. Well, like...
The targeting won't affect her, sure.
I'm sure.
All right, then, let's do it. Okay, I'm definitely not touching anything at all. Will my hair actually stand completely on end?
He didn't get a shock just now, yeah.
Are you sure you know what you've signed me up for? Of course we're sure.
Naturally.
Remember, I am truly risking my own personal health here, you know?
That faint, distant, peculiar
Nikki, can I talk to you for a second? I want to know how you feel. Share with everyone what sensations you have when you're standing in that Faraday cage. What do you feel?
Honestly, when they close it and you're standing there waiting, it's scary as hell. You just don't get it. It's especially scary because of the camera. You're just afraid for the camera, honestly. You don't really care about yourself. But when they turn it on, it just smells like ozone and it's a bit loud.
Yeah. And when it's right there in front of your face, what do you actually really see?
I see the camera lens.
I asked them to do it again so I could record the shot. That's it.
Okay, got it.
Everything is completely clear. That is indeed a truly professional trait. All right, got it. Thank you very much for your kindness and consideration.
Look closely, you can clearly see the electrical discharge in the thermal imager's display.
Cool. And
So, kill anyone, distance far.
for just now,
The distance is large.
thermal imager.
Have a video yet?
Yeah, go ahead.
Let me open it now.
So first, we're all going to begin by taking a look at... Well, yeah, let's listen carefully now.
We are perfectly fine with it. First of all, the main switch was precisely in the middle position, indicating a neutral or off state. Secondly, there was clearly something actively cycling here, suggesting a repetitive process or component movement within the system, like a terminal, perhaps a command line interface, located somewhere within the vast network of interconnected systems. No, there's no smell. No distinct smell. Let's check the resistors just in case. Are you sure you can connect resistors to the turn signal? It's turned off completely. That's it, completely off. I just turned it off now, after the fact.
There was some unhealthy sound, a distinct and concerning noise that suggested a significant underlying issue or malfunction. I didn't like it. Unhealthy then.
This is very unhealthy indeed. It's quite detrimental.
Got it. I understand completely.
Did it dry out? Oh, yes, indeed. That is absolutely correct, without a doubt.
Basically, the soft start system didn't work at all, so we had this on and we just turned on the main power switch. What did you have turned on? Nothing. This particular one was indeed pressed, and we actually pressed this one. Well, you really need to do it quite like this first. Oops. No. It certainly would have leveled... Did the button get stuck or something? It was the same sound. What tripped?
The circuit breaker.
Which one? The stamper one. Found it, found it, found it.
Ah, that one actually tripped.
Perfect. Thank you. So, are you going to the teleacoustics? We're choosing now. What happened? I removed the cage. Everything works. It was just a pulse. We need the circuit breaker.
That's the arc and cage reason it doesn't
work anymore. Well, we'll go without the resistor. Arc or cage? Is this really safe? We won't be able to provide a smooth start without the resistor. Well then, we'll have to remove it there. Discharge it? No.
Look, we can keep the power under voltage. No discharge it. Disconnect the discharge circuit. Anyway, don't...
Say goodbye. Just make sure to say this is a safe conversation here. Can you insert it?
Somewhere?
Great. Everything is completely fine. No. Well, so we'll go without charging then. The discharge has nothing to do with it here. No, we need to drop the tabor. We haven't charged it yet. There are some details. We need to leave everything as is.
Aren't we going to turn it off? Well, if there's no tabor, we won't turn it off.
Turn it on, turn it on, turn it on.
Green, green. Electrolyte charging is now active. That is currently...
It is indeed quite very true.
There, it's through a resistor for each phase. That's very interesting.
For those who understand at least something about this. And then,
the reason the time doesn't
trigger, the resistors are already being shunted.
Contactor is an electrical switch.
Or perhaps, by the way, the crucial diode bridge. Maybe it has completely blown out. It's entirely possible that it has already failed. We absolutely need to thoroughly check this specific component. Let's check first. The diode bridge could have potentially blown, by the way, causing a significant issue. No, it couldn't possibly have blown. It's a very heavy-duty cable. Yeah, the cable is quite long, so let's thoroughly check it. Let's check. It is crucial that we thoroughly inspect the diode bridge. This component is vital for converting alternating current into direct current, and its proper functioning is essential for the circuit's overall performance. Therefore, a careful examination is necessary to ensure its operational integrity and to identify any potential issue.
Yeah, just as a clear and helpful indicator, for everyone to understand. We are going to be discussing the topic of in this segment.
We are in the process of gradually and carefully increasing the power output. At this precise moment, the power level has already reached a substantial 800 units, indicating a significant advancement in our operational capacity. With each successive iteration, so to speak, we just kept on going higher and higher, reaching new levels. Now, I will carefully cut it open. It was basically working as intended. 2 specific charging resistors burned out there, but that's not a particularly big deal. That's a soft start mechanism, so it doesn't hit too hard, so to speak, protecting the components. Do we have any powerful incandescent bulbs? We'll check the diodes now.
Speed 15 kilowatts. Let's go. Let's go now. Indeed, now we can, right? And proceed.
Let's see, if the Limos is running, maybe it's still running now? I was piloting the Limos the whole time, right? So, for the heating element. Let's check it now so we don't have to run back and forth twice. Let's check it. Semenovic, first of all, we need to open that side too, so that... Yeah, from here, basically. All right, let's take it and first change the position. Yeah, switch it. It's better not to drive with this kind of comfort. And is there automatic discharge over there? The most important thing to remember is to absolutely not change the electrical current. This is a critical instruction. All right, please go ahead and thoroughly check everything to ensure it is correct and functioning as expected. Let me take it like this. One more time. And we worried that 1.28 fine for you. When I carefully took off the mesh, my wire completely melted like this, and then it just evaporated away. Even though it wasn't short at all, a little bit. That's electricity, not particularly short. In just a few seconds, the whole loaf was gone. It's a shame for the people, not short.
I need to know, did you manage to successfully fix the problem? Have you indeed resolved the issue completely?
Yeah, we have indeed fixed it. We now need a log, and we are going to burn it now.
With just some oil, perhaps?
Will that work?
Perfect. It'll catch fire more interestingly.
That's it.
We actually wanted to take a stick, perhaps a sturdy one, and use it for a specific purpose.
No, let's definitely take the log. There's absolutely no getting out of it.
Weathered, old, decaying tree stump.
Charged up really well a few times. And it looked really beautiful and quite...
We are just like children, full of wonder and excitement, approaching everything with a playful curiosity. You need to press it firmly and then turn it. The main thing is not to, under any circumstances, forget.
Make too much dust. Yeah, but you have to do it quickly. No, I mean, we need to take it. Yeah, it evaporates. Let's do it. Great. Once the arc starts, it'll catch fire 100%. If anything, step back, let's light it up. Awesome. Don't touch it with your hands. Is it ready? It's better not to touch it, really. Preferably, please don't touch it. Okay, look, just put it back now, all right? Oh, are you actually coming here? No? 1, 2, 3. Put it back! Gentlemen, I assure you I don't want to go extinct. You got me on. Stick firmly in place and securely.
Sorry if I'm really not.
Right about something.
I am finally back. No, my dearest lovely sweetheart. Just a regular MIDI.
It went completely right through indeed. Good heating, that provides warmth. 41 degrees. That's just the soft, flexible silicone. I don't see any visible major burn marks or any significant damage.
Over there, a few small dead grasshoppers are lying around.
Yeah, indeed, 41 degrees. That's fine. So how does it feel?
Well, I have to say, it really turned my soul inside out. I almost freaked out. Pretty cool.
Scary?
Now, what's so scary about it? I trust my mom, the physicist, but I still wouldn't throw a hairdryer in the bathtub, sorry. That's what they're zapping, those the seers.
Come on. Can we get the light? Hold on, it turned off.
Oh, yeah.
They just crawl around and then get zapped. Guess it just truly wasn't meant to be for them. It's just the same thing there. You have to clean it up properly and then re-glue it. In precisely the same spot. It's probably best to just stop right here. It's already completely charcoal there, so it's utterly pointless to continue. You have to stop. You absolutely have to clean it up. You really need to clean the copper and the tin at that specific spot. I think that's probably enough for today. Yeah, we should pause so we don't burn it through. Tomorrow we need to bring some fast-setting epoxy.
So this is its insulation, right?
Yeah, it really burns up quite quickly. And already we are seeing significant changes.
Did you clean the tracing?
We are looking for positive feedback. Please provide it. And just in the heat? It is important to note that this should not be kept in the heat for a period of 2 full days. See that? Look, by the way, you can see the traces.
Have you truly decided to take on this significant risk? I genuinely wouldn't recommend it at all. Have you truly decided to take on this significant risk?
Yeah. But you can use PDM.
Well, it just depends on how it started to burn there.
I truly think it will be perfectly fine. It started burning just right, didn't it? The PDM process is going very smoothly indeed.
What exactly are you doing? You are aging it. That's it.
Dear esteemed residents of our vibrant city, we are reaching out to you today because we want to tell you something truly important and significant. We want to tell you with utmost clarity and comprehensive about the crucial developments and vital information that directly impact our community and collective well-being. We want to tell you openly and transparently about the essential updates and insights that are paramount for everyone to understand. He is here to help us achieve these goals and provide further valuable insights.
He has heated up. There was a switchman. Well, it's not that close, is it? The contactors have tripped. Basically, we need to... Machine's hot. Don't turn it off. Let it cool. Discharge, I can't. Well, let's turn it on now and make sure everything works. The machine has built up heat. It happened. It's 160 amps for us. How much did you charge up? What was the maximum amperage? Well, according to the report. Now we can go measure the temperature. Now with a finger,
we'll measure it very precisely.
Your most reliable tester is your finger, right?
Meter. The voltsimetry does not work properly. Turned it on, and at 50-50, approximately 50% of the total. How much was it just? 5 milliseconds and 5 minutes. I'm telling you, it very rarely indeed burns out. You can quite clearly see it right there. It's plainly visible in plain sight.
Oh, really? You can clearly observe on the individual cell that it is actively burning, indicating a significant thermal event occurring right before your eyes.
Oh, yeah.
I'm not entirely sure, but yes, there should definitely be something that has been burnt up there somewhere. Let's take a closer look and investigate.
We'll see if it's clearly visible. This is truly reliable construction. Look closely.
The ball. Yeah, look, it melted.
Yeah, of course it's going to be quite difficult for him to clearly see it, especially at night too. Yeah, that's right. Damn, that's crazy.
So, what it does is it actually burns the Ural with extremely high voltage, and the electrical currents here are just absolutely insane. And also,
the little log is burning. Well, this construction, it's really
reliable. It's generally much better not to show this particular information.
It's reliable.
No, well, it actually still works anyway, regardless. What? Not to really show then?
A truly reliable construction.
Reliable, of course. Grounding?
The grounding is in place. Sash, is it moving? It works and catches.
Yeah. Sanya, there's a wire over there. Did it melt? Yeah, the wire melted. Film this. The metal is literally melting before our eyes. It won't. Sanya, the ball is not going to move.
Got squished.
The ball at the end.
And here's a ball squished. Look. It burns right through.
Where is it now?
Well, this one is the most obvious. That's the one they showed. Already filmed it. Yeah, you can see there.
It completely melted, transforming from its solid state into a liquid form.
It actually didn't even hit it that much yet, meaning the full impact or effect has not been fully realized or experienced at this particular point in time.
Yeah, that's definitely the melted one. The currents here are really quite powerful and strong, you see.
Pretty strong. Well, this is a very quite interesting...
Good tomorrow.
That's absolutely very good. How much does it heat up? Didn't heat it up too much. Not in CV, but in PDM. I wonder how long it can burn in CV mode. In CV with PDM, yeah. I don't think it'll last long. For obvious reasons in the PDM, there will be lightning like this, Dem. There will just be a fat goose and that's it. Silent couple. Yes, a rather substantial and noticeable fat accumulation will indeed emerge. The most crucial aspect is ensuring that it does not originate or protrude from the lower section. You possess the complete capability to fully expand it and perform the operation for 20 milliseconds precisely once every single second. Now I absolutely need to proceed and attempt this. Will the second pulse density modulation not cause me any significant harm or damage? It doesn't suffer at all. There are absolutely no sharp impulses. PDM is very smooth and consistent. And with PDM, it sounds really soft and pleasant. The bass is just a pure pleasure to experience. And it's not loud at all. Just PDM. I'd say the regular operating modes are riskier for the secondary. And what's the pause in PDM? They're sharper. So what's the pause in PDM right now? 50%. 50-50. 5 milliseconds. Right now we were running 5 milliseconds on and 5 milliseconds pause. 5 milliseconds, 5 milliseconds pause. 50-50. The CVPDM? Yes. CVPDM. Well, CVPDM. But I was running it in CVS. CVPDM probably. Well, TSVPDM, I choose PVDSS. Yes, I absolutely say yes, we definitely need a full orchestra for this performance. Orchestra, yes. It's like trying to play the entire whole drum set.
Not bad, actually. Not bad at all, I must say.
A small fragment. Fine. Very good. Let's do it so it doesn't fuck us up. It seems like we are 3,200 there. And it's normal for her. Normal for her. How many parallel bricks do we have? Well, Saryoga, 8, right? 4. And shoulder 4. 6 and 4.
2,400.
Our current can be 2.4 kilometers continuous. Taking into account the 0.75 coefficient when you parallelize them, that is, you can in principle serve at 3.2. What was the maximum amperage roughly that it was drawing? Saryoga, right now I want Saryoga in this mode to switch to 50%. Well, to be fair, in copper. In copper during the brief pause, since it's not a continuous process, the notes are not being fried all the time, so they typically add another 50%. And
this is precisely what it's truly playing, right? What it actually looks like, indeed.
Bright, vibrant, luminous, and captivating.
You've got some kind of laptop, can't see anything.
That's really all there is to it. That's all there is to it.
We are currently filming this very important scene.
We are filming this. We are definitely filming this because this truly might be the very last run we get to experience. Let's sincerely hope that this is not going to be the last one. Or perhaps alternatively, you could say,
tomorrow we'll film how it works, or tomorrow we'll film during the day explanation of why it doesn't work. Why it works this
way or another.
Why? We came here specifically to film the intricate coil, but unfortunately we won't be able to show it to you at this moment. It's completely finished now.
yesterday. So, shall we go ahead and actually turn it on? Should I switch it over right now? I'm switching it. I hope there's no one in there. There's no one there. I'll film it myself. And
why does it make that sound? That's
contacted.
That's so
normal. A good second sound. So
is it alternating? Yes, at first it certainly is indeed.
It disconnects the coil, then it starts charging the battery, charges the battery, shunts it, and gives permission with the red light.
And there the red light is on. The green one is the OCD, but the red one is still on there. That means it's dangerous. That means you absolutely can't do it.
And there's only a single track. I guess you have prepared it well, right?
Hold on. What did you say? 700 amps. No way, right away. Simply not.
Sasha, the clamps were really jumping. They were jumping. Let them jump. That's just it. Go, please. Teryoga, just 50%. Let's go. That's an absolutely incredible, astounding 50%. Oh my goodness. Wow, that's truly amazing. The same fragment. Come on, come on. Oh, the clamps are really going to jump. Oh yeah. Come on, clamp. Hold it.
And why are they jumping?
Because of electromagnetic forces.
Just interference?
Well, no, it's actually really like up. Everyone, prepare yourselves for an auditory delight. It seems the moment has finally arrived for us to immerse ourselves in some truly wonderful and captivating music. Let the harmonious melodies and rhythmic beats fill the air, creating an atmosphere of pure enjoyment and perhaps even a little bit of excitement. Yes, indeed, it's time for some fantastic music to begin. Shit, more?
Don't cool down, Carlock. Damn.
Oh my goodness, wow.
That's it! That's it! The counter's done!
Meanwhile, we're getting the cosmonaut ready.
Wait, the classic look. Grandpa Dima, is it really gonna blow up? No, it definitely shouldn't.
What exactly do you mean by that? I'm referring to the switch, the one we were discussing.
Blue. What do you mean? Nothing's gonna blow up.
The breaker overheated, and now it's in the middle again, right? Yeah, look, now it might.
Did the breaker die?
Yeah, it might. It might burn your face right now because there's a live phase if it shorts together.
Yeah. Turn it off, substation Colia. Turn it off, substation run. And
Oh, the electrician is really running?
Well, that's more or less the situation, meaning it's generally accurate or approximately correct, without being entirely precise. Not the absolute limit yet.
It's definitely their breaker.
It's smoking.
You still can't get close to the breaker.
And how close is close?
Well, like this, that's fine.
Right here, sir, yoga.
Stop!
That's it.
And how much?
No way.
Come on, I mean,
there was a short circuit. Shine a light. Oh, that's exactly what the short was. Interface, it's all good. Here.
They got completely fused.
Not the breaker, it's the wires.
Interphase. Everything's going according to plan. This is how you have to work.
That's all. The wires should burn, not the coil.
The weather is warm and pleasant, delightful experience. Seryoga, feel it.
Phase.
I'll feel the phase. It's normal.
Phase. Warm. This one is very thin. She is the very thinnest. 35, right?
Oh, there are 300 amps of power there. The significant snowmelt has already occurred. Sleeplessness? Yes, it's stuck.
Did you turn off the phase?
Yeah. Kolya turned it off.
Tomorrow we'll need to turn off the wires.
It turned itself off.
Strengthen the wires. Are these okay?
We really need to put 50 square here. We definitely need a splice like over there with 35 square. Oh, the mush is coming quickly. Mush. The mush is coming.
Where's the mush?
The mush, right? Look, it's sticking together. Mush. Did you turn off the charge? Yes, of course. Sweet bread, look. Mush. Sweet bread, over there, look. It should be the same in the coil, right? No, these wires are thicker. How many square millimeters is that? I think
This is really very worthy. How many squares? This is indeed a worthy ending. Okay then. Let's, disconnect them now and launch them once.
Need not. Let's check that. Send.
Okay, machine gun knocked out.
Yes. Here's a very short one for you, just a quick example to illustrate the point.
There was a short circuit. This is a very good malfunction. That is, it is fixed quickly.
This is what I mean by...
This is fixed very quickly and efficiently, and in fact there is absolutely no damage to expensive components. Therefore, we call this a truly good malfunction.
This is a good malfunction.
I agree. I suggest Rumchik
go on.
It's better to lose a wire than to lose a coil.
The main thing is not to lose the coil. You can lose everything, but you can't lose the transistors, which are so expensive that basically I'll never be able to buy them. That's it. Because that's some very serious equipment. Everything else can be restored. We said, Dima, that's it. This is the last time we're starting it up. Well, that's basically it. You should have
said it more carefully. You jinxed it.
There you go.
Let's film the culprit, the one who said last time, and...
That's it, and that's the whole story. I think we can really just leave it like this. I think this part right here, the only thing is indeed quite this. What's this here? That's ground. Ground, no worries. This goes this. This needs to be separated. And this needs to be laid out like this. That's it, absolutely perfect.
Alright, we'll leave this here. Let's leave this here for now, just so...
We just don't ever truly lose it. Carefully lift it up, and then we will gently slip this particular one right underneath, ensuring it is perfectly positioned and securely in place. And we'll grab another microcontroller. It will definitely need to be carefully programmed in order to accurately measure the temperature remotely and effectively. Alright, that's all. Okay, here's the nut. Yeah, I'll reach for it. Reach for it, yes. And these other ones too, please, also indeed. All good again.
So, is today going to be crazy?
Today's going to be crazy, yes. We're even going to reprogram the ESP32 microcontrollers now to remotely monitor the temperature of the semiconductor devices in the Tesla, because it's actually dangerous, and we're a bit worried about them. And we truly hope that today, we will achieve a record-breaking discharge current. Yesterday, we were drawing approximately 480 amperes from the 380 volt mains. Now we want even more. So, we are running a double line with SIP cable, right along the ground. This approach ensures that we want to minimize line losses to deliver more current and thereby increase the load capacity. Fortunately, we have a 400 kVA substation with a recloser available at our disposal. This substation was specifically set up for the Tesla, as we mentioned.
The car has been brought in.
Yeah, this is quite an absolutely unprecedented and remarkable luxury experience. And basically right here before us is our magnificent Tesla. We've meticulously set it up and are patiently waiting for the arrival of nightfall. Now we'll hook everything up and wait for the launch.
Most likely not, because its rated current is a substantial 600 amps. No, well in any case, there was a noticeable drop, but I truly think it wasn't more than 5 volts, perhaps 10 at the very most. This is because the transformer usually has some inherent margin. No, it
won't be insulated at all.
That is 630 in a pulse. I think it could even be 1000. You could try welding it, by the way.
Wrap it up securely and then weld the ends. It will definitely hold together.
Well, if it's 50 volts right here, then it's approximately 60 volts at the very end. 60 volts at 300.
Amps, which is short for amperes, the unit of electric current. Look just very how.
I tack it then.
Please go ahead and wind it up. Thank you sincerely for your kind attention and for listening. We've got a little something special for you right here.
Everything is completely and securely and firmly fixed in place. I think you should have just taken an aluminum plate and attached everything directly to it.
same as that other one, right? Those always get ruined, but this one certainly doesn't really...
It singes the skin a little, causing a brief, sharp sensation, but despite this momentary discomfort, the entire process is remarkably quick and efficient.
Against the background of the fence. So that...
It's visible, yeah.
Oh my goodness.
A little higher.
Yeah, that's cool.
Right here, you can see it really well.
Oh my goodness, ow. It really smells quite unpleasant, right? No.
You can really see 1 out of 5 charges very clearly indeed.
It's really very good at night.
Yeah. Well, we'll wait.
The assembled stools. I carefully moved the leg back into its proper position. A Tesla gun made out of various pieces of scrap and sticks.
Yeah, but it still works.
Oh damn, look at that. It's sizzling.
It stinks. Greetings to you all.
So
how about you?
Yeah, well, nothing special.
Still good, still? Still good. Still festive?
Festive.
Of course.
Put your hand here.
That's good. That's good. Oh, by the way, yeah. I know what this is. Go to hell, I know exactly what that is. That's very festive. That's really quite good indeed. Get that away from me. That's precisely what it's called. It's called a holiday, you know, as a matter of fact. So, how did you fry it, dude? Yeah, damn, it's so cold.
They really should have done it differently. Well, they certainly hammered it in with considerable force. They actually used large, heavy sledgehammers to do it, but I suppose it will ultimately do the job. Actually, ideally speaking, it should have been done another way.
But there wasn't really another pipe available?
What did you just find?
Yeah, that's indeed really quite bad.
Actually, people really just come here to work.
But when you do everything yourself, you know for sure that you did it right.
Yeah, that's true. It's actually better to do everything yourself because we're redoing the panel. The best help is when...
Don't get in the way.
Best help, they don't get in the way. But launching in the mountain vanilla is boring too.
Launching, yeah.
And doing how...
How did it go with the panel? When will it be ready?
It's ready.
Already ready. Almost?
All that's left now is to carefully connect the wires. There's a significant amount of current. And this is a SIP wire, which is usually used on lighting poles. But actually, they ultimately decided to just lay it directly on the ground, much like a long cable. But it's the cheapest option and it works. But unfortunately, it might not really be quite enough. So we have to make 2 lines out of the bushes. A parallel so that there's enough current. Because a 50-volt drop is, of course, a lot. That's a lot. How soon?
Can we please call Dmitry for the launch?
Well, I think in about 25 to 30 minutes. Over there we can hear some wonderful sounds. That's sledgehammers crimping the sleeves. You probably already filmed it. Yes, while I was at the switchboard. The inventions.
Of reliability and safety.
Reliability, as the classic saying goes, is truly essential. So, basically, I sincerely hope that it absolutely won't burn out prematurely, causing any issues.
Yeah, right.
Sir Yoga, let's talk about the transformer again. Are you going to keep filming? About the transformer? Go ahead. Tell us about the 50 volts. That's a good line. Yeah, I measured it. We have a voltage drop of 50 volts on the wire.
Did you measure it on the transformer?
I don't know, I didn't measure it, but I think it's on the wire, including the wire, and also on the transformer. And
on the transformer?
Yeah, it's not perfect, but
Today we'll check just how imperfect it is.
Not perfect, yeah. The transformer isn't holy, so to speak. Just how imperfect
the transformer's life is.
Need to sprinkle it with holy water, it will become holy.
Yeah. We need to...
Call a priest.
A priest?
These are, in actual fact,
the very
wires that actually melted on us yesterday.
Yeah, now they are indeed new.
Now then?
They're new and all the wires are thicker. And...
Were they 25 to 30?
Some were 16, some were 25. I think they were 16. Well, 3
black ones went through.
16. And in the Tesla 2, it's 16, already closed up.
And this one need replaced? No, this one doesn't.
Blackened. That's a result of previous ones. It's a control wire for management.
Most likely those ones.
Probably. It's a bit sooty, yeah, but it's just a control wire. It doesn't affect anything. So what are we running into now? Well, besides our madness with resonance. With the resonance of the pads. With the resonance of the coil, yeah? So there's a capacitor there.
No.
We don't precisely know what specific kind of capacitors we really need, and we don't actually know how they're going to behave, because at first we initially took capacitors from a high voltage test site. They absolutely didn't work at all. Then we subsequently took a capacitor, something like 75 to 90, which was quite similar but a bit better. They did work, but just barely. Then we tried a German capacitor. They worked too, but even worse. Now, the French capacitor from an impulse medical device seems to be working quite well, but again, just last night, one of them unfortunately died. And, in other words, we'll have to constantly and meticulously select appropriate capacitors, and most likely assemble a custom battery from a significant lot of many small individual capacitors, essentially building our entire own unit completely from scratch, doing absolutely everything ourselves, because these crucial capacitors have now undeniably become the primary weak point. Who would have ever thought, so to speak, that these essential capacitors would turn out to be the ultimate weak link in the system? But that unfortunately is the stark reality today. At least this is a problem we can fight against, unlike with regular transistors.
But are we going to fight this mess?
We won't be fighting this mess because the laws of physics haven't been repealed. So, if the wires are welded, well, the current flows, it flows. And thank goodness for that. By the way,
this actually looks better than when they're twisted together one by one. Yeah.
This is the most promising method. Probably we should endeavor to do everything exactly like this on a global scale. We'll utilize a thermal imager to clearly see what it's like to be a wire welded with TIG. And basically, after that, we can then draw some conclusions. Well, I'll put it this way. In power grids, they actually do weld wires, really, bus bars. Argon welding is considered a pretty good technology for this. Of course, it's not quite like this, not in such field conditions, but it's definitely possible. It's definitely possible.
Yeah, that's true. All that's left is to straighten the wires. Everything was done very neatly. But why is it that here we have just one single wire going through?
This is copper wire, copper aluminum, two
connections. Two connections. It's not a
connection, it's just terminated so it doesn't get punctured. So it doesn't get punctured. So it doesn't get worn through. So it doesn't get worn through against the metal. Then yes.
Yes, indeed.
And in addition to that,
it appears that there are precisely 3 distinct twists within a single meter.
I suggest we compare expectation versus reality. What exactly do you truly anticipate from this particular experiment? I had genuinely expected
that we would film for 10 to 15 meters because the entire idea of building the absolute biggest Tesla coil is indeed very complicated. While you are thinking about making something the biggest, others are also thinking the very same thing. It's actually quite a significant challenge.
And in addition,
maybe they're not just doing it, but actually surpassing their own results. Accordingly, right away I decided that it should definitely be at least 10 meters or even more. To get ahead, as Alexander so aptly said about the Americans, that's truly how it is. Then in fact, to truly surpass them, you will need to build an even more incredibly powerful coil, and at the very same time, they can certainly build one just like it. So it's kind of like an ongoing arms race. Well, nevertheless, I believe that most likely we will achieve our goal. Because even yesterday at the launch, it was about 10 meters. Now the current will increase, the voltage will also go up in fact, and we might very well be able to get down to a significant depth of 12 to 15 meters already. That's probably how it will be. Unless we burn something out, of course. But I truly think that if someone else decides to build the absolute biggest Tesla coil, then we'll all certainly come together, so to speak, and significantly improve our own coil, so that ours definitively remains the largest anyway, without a doubt. But this phrase isn't new. The owner of the world's fastest truck with a turbojet engine said the same thing. He's from America, and he said that if someone truly claims that my truck isn't the absolute fastest, that their truck is indeed faster, then we'll certainly get together and make absolutely sure our truck really is the fastest. Because this is that person's entire life's work, and essentially, it's our dedicated life's work too. For many of the significant number of active participants, this particular coil makes up a substantial and integral part of their daily activities. In other words, people put a lot of effort and genuine passion into making this a major discharge.
Interesting. Does it look like crop circles from the outside?
Yes, when you're driving by, you can clearly see the impressive coil. It stands right there, quite visible from afar. People probably won't stay, they just don't know what's ahead of them. It
isn't sparkling yet.
It isn't sparkling yet. Yes, but if there were lightning, then it indeed could.
And what will be the outcome of the experiment? You'll see a little bit later. Just stay with us for now. That's all. Yes, now that's safety. I can't vouch for your safety at all. Now that's a story. You know, we definitely need to mention that this was quite intentionally done on purpose. What's with the heating pad, indeed? A medical specialist absolutely said that it's safe there. Yes, safety is crucial. Now I'm even more doubtful.
Don't worry, it's safe there. I've been there. Everything is reliable. You're crazy. I'm not a specialist. You're crazy.
It only doesn't strike the crazy ones. If truly crazy people were to fall from the 9th floor of a building, they would indeed survive. You certainly wouldn't add that information, would you? It is absolutely true. That is precisely how it is.
Well, you have to experience it yourself.
I'll go in.
Right. Did you check the diodes there? Is everything okay? I checked it yesterday. Come on, Coil, give it some power.
Let's do it first. No, first I'll
just quickly check it for a moment.
Sasha, give it a spin. I'll look at the LEDs.
They're all of them blinking quite well, as expected, probably.
I'll just tell you exactly when. Go, please, right now, everyone. Great, please go ahead and turn it off now. That's exactly what I meant. Thank you very much.
It's truly
working, but why?
Did we have to turn it off? We needed to return it to its normal position because now we'll be under
power. Oh, yes, indeed.
So was that just truly a test then, after all, I wonder?
Yeah, that is absolutely and completely correct and true.
Oh, seriously?
I like how everyone immediately stepped away from the connection point.
Yeah?
Well, that means people are generally aware of the technical safety aspects.
No.
It means
Many people have already seen exactly how it's done now. Got it.
Now, I am just checking. I'm just checking on this. Are you currently filming this moment right now?
Oh my goodness gracious. What? Is it actually working now?
Yes. And 2 warm ones and 2 warm heating elements for the first charge. Very good.
Such a big cap. They will just handle it.
All right, it appears that no one is here. Just drip, drip, drip.
So then, well, now actually, I suppose.
Is it working?
Yes, it's already on. Everything has been started and thoroughly checked.
Okay, stop. Please be very, very careful. It's a live broadcast here. 47. This is the number we are looking for.
And 6, just like before. I don't have enough memory.
Either. Also 47.6. Or does it need to be refreshed? Refresh it?
Yeah. Okay.
Same thing. And right here.
It is quite important.
Should already, as expected, indeed be the case.
Be 6 meters.
No, it's quite the same. Something quite deep is clearly jumping there. Now that's definitely a fault.
Or perhaps it is simply the ambient lighting emanating from the streamer's setup, making the exact source of the illumination quite unclear and difficult to discern at this moment.
There was something there, yes.
Where?
No lighting inside.
Donut is not clear.
Let's just see then.
Do you have a drone?
We didn't have any. Yes, yesterday
I just saw...
harsh, intense glare.
From somewhere? Blick open from where?
The second one is cleaning up, actually, indeed.
Okay, the cable definitely helped. Yes? And so it did.
10 also helped.
Does the heating element get warm?
Barely warm. It shouldn't be warming up now. Now he is cold.
What? He has already done his job, indeed.
He's only on
launch. It's just barely warm, even when it really starts up.
I spoke. However, it is truly quite impressive, demonstrating remarkable qualities and an exceptional standard.
Very much.
Certainly, yes, indeed.
How many exactly are there?
3,600.
Fine. The Devil's, you know, that notorious place everyone is always talking about, the one with all the stories and legends surrounding it.
So in order to do that, we need to consider all the factors. Could you give me another one, please? Well, let's really take some beautiful pictures now. How long exactly will we just be?
K-hertz?
By a total of 2.
Kilohertz, 50 degrees already. And what? And just a moment.
Power off diode.
A bridge to the crucial, relevant, and important information. Number 51.
Did you turn it off?
No, I appreciate your offer, but I must decline.
Well, that means it turned off by itself.
Did it actually turn off? Okay, wait a moment, Lyoka. Please don't turn it off just yet. Let me quickly check what specific light is currently on there. I will tell you the exact details in just a moment.
What is something that is yellow in color?
Yellow, yeah, that means it's overheating.
By the way,
the temperature.
We are currently working on resolving the significant overheating issue. Should we proceed to turn off the bridge system?
Yes, I'm in the process of switching it over to the safe mode at this very moment. What exactly has happened here? The bridge shut down due to overheating. That's a good protection mechanism at work. It's thermal protection.
Excellent. We're definitely getting some wonderfully warm air blowing through now, which is a very good sign. Now, with this positive development, we can really begin to warm this entire area up.
Yeah, it's really hot from right here. Now that's some truly real heating. On the gauge, perhaps? Probably 50. That's a pretty decent warm air gun. Wow, that's really something. We've never heated it like this before. Wow, yeah, it's really heating up quite nicely. Yeah? The producer. Producer. Well then, I will see you. Sonia, that's absolutely it. Okay, fine. Yes, this will definitely end up in the video. Yeah. Man, well, of course, everything will be available in the video on the internet, you know? Why? On the contrary, well, you know, it's quite clear. Well, it's quite evident. Well, you know, it's quite interesting to consider this particular point. Well, you know, you have to. Well, an oil radiator. You have to make an oil radiator. Yeah. Well, I think, you know, it's important that you securely fix it directly to the mounting plate, and then you must carefully calculate the necessary measurements. I personally have a dedicated thermometer for monitoring the temperature of the oil circuit, approximately 50 degrees for the oil circuit, you see. This particular radiator clearly states that the gate is indeed oil. But it's not that it's really cold, it's that the watermelon is actually very boiling.
Is it actively leaking and dripping onto the floor right now, creating a noticeable wet spot or puddle?
So, to summarize the preceding points and to provide a clear transition to our next topic, we can conclude that based on the evidence presented, it is imperative to consider the following aspects in detail.
Yes, we switched over.
Did you just switch it?
So, what's up with this, do you think? We just didn't tune it yesterday, Duma, and here it's actually very important for the coil that the resonant frequency of the primary winding precisely matches the resonant frequency of the secondary winding. You understand? Otherwise, you absolutely won't get that significant voltage increase. So right now, we are carefully selecting that specific frequency. Got it. Without even properly tuning the resonance frequency?
It will work either way, you just really need to accurately catch the absolute maximum point. So you have a classic Gaussian distribution curve, and you can be positioned to the right of the prominent peak or to the left, but you absolutely need to hit the very precise center point.
By the way, right now it is currently sitting at the very top of the upper peak, so that is absolutely impossible to achieve.
That's what the high voltage variable capacitor is for. There aren't any of that size, only vacuum ones.
Currently there aren't any of the specific size that we need. Of course they do exist, but they're about the size of your
garage. So this is where we keep all of our vehicles and other stored items.
Now we really need to go and pick up the beautiful brooch.
And, in light of the circumstances, what's the capacitance of all these capacitors? There are that many microfarads. Seryoga, how about we go with an offset? With an offset?
Well then, with the offset.
Are we going to break something?
No, unfortunately, we absolutely cannot do that under any circumstances. And furthermore, it is simply not possible.
So, where exactly were they just not properly installed, or perhaps even correctly fitted? This is just at the factory where items are produced. This is actually specifically intended for all amino acids. It's currently lying completely still inside at this very moment. It was definitely there
constantly circulating throughout the entire time. Once, during a live performance, had a small washer in the coil, and unfortunately the washer didn't have a proper grover. Basically, it's actually connected directly on the DC bus, and we're sitting 5 full meters up there with the coil. Suddenly it just flies right out of there, quite unexpectedly. We almost fell completely off in that very position.
Quite directly.
The piece of copper just got ripped out right there.
There you are, my friend, right there.
The coil was smaller, but still it was.
And the diode
it was already actively charging. We then climbed up to carefully adjust it.
So it only picks up drops?
Yeah, we didn't even have a single Robilier needle.
It actually picks up all the drops. So why would you put a Robilier in there?
Kolya.
Are you looking at this one?
I thought you had to stop.
Yeah, that was quite an experience, truly memorable and quite impactful indeed, a moment to cherish.
I thought you stop on your computer, Sash. Why doesn't your computer stop?
The very last thing that we need to consider is this.
I thought you guys could lower the power. What happened?
There was a breakdown from the secondary winding to the primary winding and to the case.
What happened?
Well, why is there a lack of music playing from the laptop?
Because you can't stop it quickly? No one stopped it, so I had to turn it off manually. With the remote, so to speak. The temperature here is already 39 degrees. Or rather, 49. I apologize, so this means there's already significant heating. Now we need to check what kind of damage there is, but I hope it's minor. As usual, we'll clean the coil, and then we can try running something again. Basically, there was a breakdown yesterday, but that's typical for this situation. A breakdown because the voltage is too high, and it's simply impossible to equalize the potential. So all you can do is pour it in, wait for a breakdown, clean it, and pour it in again. Pour it in and so on. The Tsarichnaya winding is coming apart. Mercy.
Yes. First of all, it didn't quite fit.
Yes, you asked what they did to you. They all just jumped out themselves.
Yes, I heard that. Did you see how the lightning hit you?
It just got red hot.
No, it's right on the left.
Yeah, there. Well, over there, everything is bent horizontally. So did it get roasted? Here's the hole. Yeah, it burned right here. This is yesterday's hole. Oh, wow. The main thing is, did it burn through? Yes. The main thing is the transistors, yeah, they got blown out. It burned through. The transistors? I saw it over there. It was really beautiful. It really was.
And why? And you didn't notice it right away, did you? Yeah, I thought maybe they reduced the power from the laptops or something, but unfortunately it wasn't possible to lower it from the laptops, so it burned through. Then it was already an emergency. I realized that it still wasn't the right one. I welded it. You forgot. You would have filmed it, right? Twice. Did it twice. And I adjusted everything right up to the top.
But they are involved in this, and it was clear, but from this side it's very
juicy. Absolutely no comments at all. No tracks whatsoever. Nothing to be found, nothing at all.
higher up.
Higher up.
Well, come on then. Let's definitely do it with full and complete manual control.
Here it is, located right here. This particular item is truly exceptional and remarkably good indeed.
And you noticed right away the silicone got burned, right?
Yeah, exactly. Right here.
You can see it here. It flared up from below. From below too.
It unexpectedly flared up very quickly. It flared up from below too. A lot indeed?
Yes.
We need to clean it. Let's truly take a look inside because the burn-through goes right inside. It can't go lower than the plywood. Got it. It most likely went into the strike. And this here cracked. Was it from scratches or did it just crack? No, that's a layer on these strikes. You never know. Alright, anyway, let's start running it in the PDM then. Let's max out the power. Well, we need to wait about 20 minutes until it's clearly overheated, lost.
Are there any more traces? At least it seems like it.
It's even hotter, much hotter indeed. Well, it certainly gave us about 20 minutes, a good 20 minutes. Alright, that's it. Take it up to speed. So now, in PDM it started working worse, but in the DR it got better. So, what do we need? I'd bring the caps back. It needs to be clean. And I'd start it up in the PDM properly, and that's it then.
We need Serioza. For Serioza. And what if we raise the second one a bit? Well,
alright, let's eat right now. And now, General, started working worse in PDM. On the big stream less.
Red coloring?
No. You want some? Here on the big survival streamer? No, now it's clear. And what if we raise it? What will happen? Will it burst? What? The red coloring? It will actually work worse when it is raised. When it is raised. And in the hole it works much better, right? If that is so too. I'll start now. Alright then. Well, so let's just bring the cat back, please. Will it live? It needs to. It'll last a bit longer, yeah? That's it. So the question is what? Then let's shut off the hole.
The main thing is we've got the shot. Time to sum up. We've taken apart the coil. First of all, I truly want to express my deep and sincere gratitude to Dmitry and the entire DPLABS team for helping organize this event, because it's pretty difficult to arrange the logistics, help with cranes and manpower, so... And here's Dima. He just took it, said it, and did it. It's really nice. Yeah, to provide power by the cable. Dima also contributed financially to this. For that, he deserves a lot of thanks. So, what are our actual results? What we planned was that the coil, when we designed and built it, would be around 150 kilowatts. Well, now we've increased the range to 200 as a result of the tests. That's it. So, we've actually found out that this particular coil can basically operate quite effectively in the 150 to 200 kilowatt range when it's in music mode, playing back various musical tracks, which you will soon see. The absolute maximum power setting that we could possibly achieve, yes, and honestly, we genuinely wanted even more power than that. We absolutely had to load it up to its ultimate maximum capacity until something would inevitably break, so to speak. We were betting that it would be the high voltage capacitors, but it wasn't. In the very end, we ultimately hit the thermal limit of the transistors, and at some critical point, when each individual one was dissipating about a full kilowatt of power, one of the transistors just simply couldn't adequately handle the immense load. Oh. Well, our next steps will be to increase the power further. We'll probably replace the 600 transistors with 900s. In other words, to solve this problem, we'll also rebuild the capacitor assembly. After that, we'll further improve the insulation of the secondary winding. You understand, right, that when the voltage reaches several million volts, the winding is also wound at a relatively short distance. They can break down onto themselves rather than where we want them to, where we expect the discharge to happen.
And also the deadly dragonflies, yes.
Yes, and everything was completely covered with countless insects. It was truly like a graveyard of insects all around the toroid, really. Well, we don't exactly welcome such occurrences, but what can you truly do? We launched it outdoors in tough conditions. The temperature was over 30 degrees. It's scorching hot in Moscow right now. As you know, the forests are burning, but we managed to do it before autumn, before the rains. All of this is really wonderful.
But the goal here is a megawatt
someday. Yes, well, the goal is a megawatt, yes. And maybe that's exactly what's needed elsewhere. Yes, I think if we make and prepare the coil, in other words, what we ran into now is that we didn't have enough power from the electrolytics. So the first pulses were very powerful, but then the network sags at such high power levels, and there are voltage discharges in the DC circuit, which is basically the inverter, and it drops sharply. So we need to make the same kind of coil, the base. Bring in electrolytics or something more powerful, maybe supercapacitors, connect them in parallel, and then we'll have a stable discharge. Well, I think sooner or later, if our coil is 7 meters or 14 meters under special conditions, we'll get it on camera. It's not about continuous operation, but rather setting some kind of record. So, if you know of a coil more powerful than 200 kilowatts, leave a comment and we'll take a look. Otherwise, we can officially announce that the goal of our event was first of all to introduce this coil, to show that it exists and works in Russia. And the second goal was to test its power. To test its limit, take 30% off the maximum and say that this is its actual power. At startup, we reached a peak power of 300 kilowatts with 600 amps through the three-phase network. That's 600 amps per phase. If we reduce it, that comes out to approximately 300 kilowatts. Take off 100 and we get 200. So there is a 200 kilowatt coil in Russia.
With 11-meter discharges? Yes.
The maximum discharge we recorded in the photos ranged from 7 to 11 meters. So there you have it, thanks to Dmitry. Subscribe to the channel.
Yes. I also wanted to give a special thanks to this guy. I really enjoy this. Great show. I've always wanted to see this in real life. I really like it too. I really like high voltage, but it's kind of scary. As you all know, I have issues with safety protocols. I really, very much indeed, liked your determination. The coil is awesome. I truly think this absolutely won't be the very last time we see it. Just a little bit more. Thank you all so very much. Please subscribe to the channel, share, like, and we will see you all soon. Safety, where there's indeed safety, that's the face of it.
Safety is truly sitting right here, indeed, in person, with us.